Okay, so I'm going to talk a little bit about capacitors, and I'm going to start off by actually talking about the resistor. So we know that a resistor obeys Ohm's law, V equals IR, which says that the potential drop across the resistor is equal to the current flowing through the resistor times the resistance of the resistor. Now, the resistance, R, only depends on the intrinsic properties of the material that the resistor is made out of and the geometry of the resistor, L over A. So that means that I can't change the resistance of the resistor by changing V or I. R is fixed. So if I want a new resistance, I need to get a new resistor or change my resistor in some way. Similarly, for capacitors, the drop in voltage across the capacitor is equal to the total charge on the positive plate of the capacitor divided by the capacitance. And just like resistance, capacitance is also fixed. So I can't change the capacitance of a capacitor by changing the charge on the capacitor or the voltage across the capacitor. The capacitance is only determined by the geometry of the capacitor. Okay, so what does a capacitor do? What happens when I connect a capacitor to a circuit? So here I've drawn a circuit with a battery, a resistor, and a capacitor, and right now the circuit is open, so there's no current flowing through this circuit. As soon as I close the circuit, initially the charge buildup on the positive plate is 0. They're the same number of positive and negative charges on each of the plates. As soon as I close this, positive charge is going to start to flow away from the positive terminal of the battery. It's going to go like this. And then when it gets here, the charges can't move across the capacitor because there's an insulator here. But on the other side, I have positive charges flowing towards the negative terminal on the battery. But that's exactly the same as having negative charges moving in this direction. So what's going to happen is I'm going to get negative charges building up on this plate and positive charges building up on this plate. So once I close the switch, the charge will start to increase, which means that the voltage across the capacitor will also increase until the delta V over the capacitor is the same magnitude as the delta V over the battery, at which point current will stop flowing. You're like, okay, that's all well and good. But what happens if I have two capacitors in series? So I have my battery again. Here's a resistor. Capacitor 1. Capacitor 2. Okay, so now as soon as I close this circuit, the same thing that happened with one capacitor is going to happen with two. So positive charges are going to start flowing this way, and they're going to build up on this plate. And negative charges are going to start flowing this way, and they're going to build up on this plate. So, what about this piece of metal in the middle here that's not touching, it's not connected directly to the battery? What happens there? Well, this is just a piece of metal. This is just an eye-shaped piece of metal, which is a conductor. So what happens if we have a conductor and we bring a charge close to it? So initially, before we brought the charge in, charge was uniformly distributed throughout this conductor, so positive and negative charges were uniformly distributed. When I bring the positive charge in, the positive charges over here are going to say, hey, I don't want to be near this guy, so I'm going to move over here. So all the positive charges will pile up over there, and that means we'll end up with negative charges on this side. And that's exactly what's going to happen to this piece of metal right here. The negative charges that are down here aren't going to want to be near these negative charges, so they're going to flow this way. And so negative charges will build up on that plate. And the positive charges that were up here are going to flow this way and build up on this plate. Which means that we're getting a current of positive charge flowing throughout the whole circuit, even though this metal piece isn't connected here or here. And that's how capacitors work in series.